Hello, everyone. Great. Okay, we have some few people here. Probably some of you already know me. My name is Edsel Garcia. I am a software architect with Progress Software. I have been using Progress, now called OpenEdge, for many years since the early 90s. And today I want to talk to you about the OpenEdge on AWS Quick Start. Let me show you here then what is our motivation for the quick start. Okay, so let's focus now on this screen. Okay, so to deploy OpenEdge ABL applications on AWS using AWS best practices for security and high availability via infrastructure as code. What is the idea here? The idea is that we are building OpenEdge applications, end-tiers application with a web UI, with a REST service layer, and with the database. With this configuration, we want to deploy it on the cloud. And to do that, we are using the concept of the quick start from AWS, which brings best practices for security and high availability. And then we create all these from a template, and you will see this in the presentation. All right. So we will talk about the OpenEdge on AWS Quick Start, look at the architecture, look at the infrastructure that is created. We're going to talk about automation. A key concept that we're going to talk about as well is the deployment packages, and also we're going to then go to Q&A, but we will have a demo in the middle of the presentation. All right, so the OpenEdge on AWS Quick Start. What it is? Well, it is a quick start solution from AWS Quick Start, right? So AWS has this concept. They bring application partners to build a solution to deliver a package solution of an application or a way to deploy an application. And we have developed one for OpenEdge. The source code of the Quick Start is available in GitHub, which means that you can browse the code, see how it is implemented. Maybe you can customize it to use to make your own version, or you can enhance it if you want to contribute to the code. The Quick Start uses two AMIs, Amazon Machine Images, from the Amazon Marketplace. Uses an image that has the Progress Application Server for OpenEdge pre-installed, and another image that has the Progress OpenEdge RDBMS pre-installed. And the concept is that these images are bring your own license. So you can use it just by the charge of running the instance, and you work with your own Progress license, right? So you don't pay an extra amount for using the Progress license, you use your own Progress license. Now, the Quick Start can be run interactively using the CloudFormation wizard from the AWS console, right? So you use the web UI, you navigate, and you enter the parameters, and you run it that way. And you can also run it programmatically with the AWS CloudFormation command. And this is something that you would put in a script, and probably would be something that you would do for a CI/CD pipeline, right? So you want to have a CI/CD pipeline where you do your build, your test, and then your deployment. Well, that deployment step can be implemented programmatically with the AWS CloudFormation command. All right, so if you go on the web to the AWS Amazon Quick Start page, you will find this general page where you can enter on the search Quick Starts OpenEdge. So you type, enter OpenEdge, and then you will find this card. This is the definition of the Progress OpenEdge Quick Start, and then you can click on it. It will bring you to the Progress OpenEdge on AWS reference deployment page, And here you have the definition. What is the OpenEdge and AWS Quick Start? It is a convenient way to create infrastructure required to run an entire OpenEdge application, right? So you're running your ABL, your 4GL application with a web UI, with a REST service layer, and the OpenEdge database. On this page, if you scroll, you will then find what you will build, which is the description of the architecture, the infrastructure that is created. You can then also go to the how to deploy and the cost and licenses to learn more on the Quick Start definition. Here's the architecture. So what we are creating is an infrastructure to run, again, an entire OpenEdge application. It is created in the AWS cloud. It has a virtual private cloud that contains all the resources for this deployment, and it uses 2 availability zones. These provide high availability. Then you have a public subnet and a private subnet. The public subnet is the only one that is accessible from the public internet. And the private subnet holds resources internally that then are only accessible through the Bastion host machine or through a load balancer. So if you need to do maintenance on these machines, then you would use the Bastion host. If you are just running your application and need to access, let's say, the production web UI, then you use the load balancer. The Bastion host, the web server, the PASOE server, they're running with an auto-scaling group, which means is that based on the demand, on the requirements of the system, more instances will be run, right? So these provide a way for high availability in combination with the multiple availability zones. And then you have the OpenEdge database. So we have multiple instances of the OpenEdge database so that you can run OpenEdge replication. For the demo today, I'm actually going to run without the replication, but you will see the concept working out. The Quick Start is available on GitHub. Again, you can customize it or you can enhance it, and you can browse the code to understand how this is implemented. The CloudFormation wizard UI on the AWS console is used to run the Quick Start. You can go through the wizard, you can go to the designer page to see the multiple stacks, the multiple high-level components for the infrastructure, and then see more details on it. Here is the source code of a small shell script called create deployment. The idea here is to show you how you can run the Quick Start programmatically. And in this particular case, we're using a public bucket and a private bucket. The public bucket has the source code for the Quick Start. So if you customize it, then you can deploy using your own public bucket. If you want to, for the deployment packages that you will see a little bit more later, you use a private bucket, right? And you can see that, right? So there is a S3 bucket name, and then there is a deploy bucket. The deploy bucket is a private bucket. Why? Because you want to protect your application, right? You want to, the components of your application, right? They are code, the database, right? They are confidential, and you want to protect them. So they are deployed through a private S3 bucket. The deployment packages. So the idea here, remember, is to run an entire OpenEdge application. We want to actually be able to run this application dynamically right from the start. And the way that we do this is to basically provide deployment packages for the database, for PaaS, and for the web. The deployment package is actually a very simple structure. It's an app folder with a deploy.sh script that provides the instructions on how to do the deployment. So The Quick Start doesn't know how to deploy your application. You do. So what you do is you put those instructions into the deploy.sh in order to do programmatically the deployment of your application. A requirement, though, is to have a progress CFG file with the database package and with the pass package so that it has the progress license. If you have other ways to let's say, deploy the progress license to those instances, you can do that too. And then there is also a web folder that contains the web UI resources. Okay, so let's talk about running the OpenEdge on AWS Quick Start. So what we do here is we want to first subscribe to the OpenEdge RDBMS AMI and the Progress Application Server pass for OpenEdge AMI. In this way, you have then access to this pre-installed Progress configuration. Okay. Then the next thing that we do is we go through the wizard, right? We access the Quick Start. We actually launch this from that reference deployment page. I will show you that in the demo. And then we go into the details. We specify the stack name. We then specify the various parameters. And then we can see the creation of the stacks, right? This is in the CloudFormation environment. And then when it's completed, you actually have access to the parameters for the password URL and for the web URL so that you can launch your application. So your application could look like this. Let's say this is a sample UI, basically a web UI, just the way that you want it. In this case, we're using a UI that is based on with users can the UI grid here, and we're showing the data for the customer table, right? So this is something that you can achieve with the Quick Start, right? So you start from scratch, you start from nothing, and then you end with a working ABL OpenEdge application. And let's see this in the demo. All right, for this part, let me switch to the web browser. And in here, what I'm going to do is I'm going to run the Quick Start. So we do OpenEdge on AWS Quick Start, and we find the reference. This is a guide that's explaining how to run the Quick Start. There's a knowledge base that gives you the steps in more detail for you to go through the wizard. And then here we have the progress on AWS Quick Start. You can click on it. Here's the reference deployment page, right? The ability to create a infrastructure for an entire OpenEdge ABL solution. And then you can scroll down further, see what you will build, how to deploy, custom licenses, right? So in here, you can see custom licenses, basically the AWS resources that are used, and then how to deploy. And then here we have to launch the Quick Start. So let's launch the Quick Start. So now here we have the Quick Start. We have create and then the options, right? We do next. You can specify any name. We need to specify 2 availability zones to provide high availability. We specify the CIDR to access the machines and to access the web interface. You can specify a email address, and in this email address, it's to receive notifications of the creations of the resources. And then you specify here a S3 bucket with the deployment assets. And I have a test private bucket 1, 2, 3, 4, 5. That's the name that I'm using for the test. For the deployment packages, here are the default names for the deployment packages. This is what is being used. All the other parameters are we're going to use the defaults, which are good, and then you specify the key pair that gives you access to the resources. And this is good. We proceed. We have here an option that we can select and say preserve successful provision resources. We can use this in the event that we need to troubleshoot the infrastructure. And if we want to prevent the delete of this infrastructure, we can enable this option as well. And then we do next. We have another chance to browse the parameters, and these parameters are good. And then we proceed, and we need to specify that we acknowledge that AWS CloudFormation might create certain resources. And then we click on create a stack. Okay, and here we can see the stack is being created in progress. And I have other stacks from other configurations that are already created here. We can do a refresh and then see that from the progress OpenEdge stack, now the VPC is being created. Okay, so, and this process will take between 15 and 20 minutes. Okay, so let me go now back to the slides so that we will just let this run for a little while and then we come back. Okay, all right. Let's talk about the infrastructure. Again, what is the goal? The goal here is to create an infrastructure for an N-tier OpenEdge application. And this N-tier OpenEdge application is an OpenEdge application that is working in the cloud and is using cloud functionality, right? So this is not a lift and shift configuration that you just basically run one host server and then you do just your traditional deployment. No, this is a step further where we use AWS native services to provide high availability and to provide scalability and also security. So let's review this configuration again. We have the AWS cloud. We create a virtual private cloud with 2 availability zones, high availability. We have 2 subnets, one public and one private. This provides security because only the only resource that is available on the public subnet is the Bastion host. The private subnet has a web server, a Apache server, and the OpenEdge database instances for these machines. And it's not just one instance of them, but multiple. Why? Because we want to provide redundancy in the system, right? To provide a high availability concept. The web server and the Apache server, as well as the Bastion host, use an auto-scaling group. These provide basically the ability to launch additional instances based on demand. And then there is a load balancer to access the web server. Actually, there are 2 load balancers, one to access the web server and one to access the pass for OpenEdge server. For the database, then we create multiple instances. We have actually the option to create 2 or 3 instances. And in that way, we can set up a configuration with OpenEdge replication. And for your research, if you don't have an OpenEdge replication just yet, you can just use it with a regular OpenEdge license and basically copy the database. So let's see more of this infrastructure. On AWS, the way that you see the machines work in the configuration is through the EC2 dashboard. And here we have the instances page where we have an instance for the database, DB0, and have DB1 and DB2. This corresponds to the source replica, target replica 1, and target replica 2 to use OpenEdge replication. you have then the Linux Bastion host, which is the one that is available from the public internet so that you can use it to access the internal resources in case you need to do maintenance. And there are two instances by default for PaaS for OpenEdge, for the REST services, and there are two for the web server to provide access to the web UI. All right, so security groups. On AWS, each machine can have a configuration on what ports are available to access the machine. The security groups provide that configuration. So it starts in a very restricted configuration, only SSH access, and then we expand this to provide access for the OpenEdge database as well, right? We need to specify the minimum and the maximum port, and if you are specifying database, OpenEdge database replication, then you also need to use that range of ports that are open, okay? But otherwise, the configuration is very restricted. Here we can see the load balancer, okay? We have two. We can see the auto-scaling groups. There are three auto-scaling groups, right? For the web, one for the web server, one for PaaS-OE, and another one for the Linux Bastion host, okay? Location of files. So we have three types of machines, right? One that is running the database, another one that is running PaaS for OE, and another one that's running the web UI. Well, the ones that are running OpenEdge have OpenEdge installed on PSC DLC. And then there is a PSC work WRK folder for that configuration. The deployment packages, the idea is that they are copied into an install folder on each of these machines. And the application package that is installed, it's called just app.tart.gc, when it is copied onto the machine. Then if you look at the web machine, you have an Nginx configuration. And the location is etc. Nginx conf, and the Nginx HTML files are on var www HTML. So what if you need to do some troubleshooting? So if you need to do some troubleshooting, right, as I mentioned earlier, you enable those options, right, to prevent the resources from being deleted if the entire deployment failed. So in that way, you can do analysis of the resources. And what generally you would do is you would connect to the machines in order to analyze what happened, right? So you would look at the var log file, you would look at the install folder and check if the app.gc file was copied. You will look at the progress CFG file also being deployed, right? So if a progress CFG file is not deployed, then the database is not started. And if the database is not started, then the PaaS for OpenEdge server cannot connect to the database, right? So that's the analysis that you will do for the troubleshooting. Here we have the connection through SSH, right? And how do you do this? Well, you do SSH -i, the PEM file, right? That your key pair file, and then you specify the IP address for the Linux Bastion host. From this Linux Bastion host, you can use it to access other machines. Okay. One key component of this is that the permission of the PEM file has to be 400, right? So you would do change mod 400, the PEM file, so that it has the security required for running SSH. Notice that the instance, right, that we have here, which is the Linux Bastion instance, has a public IP address. and also has a private IP address. But the key is that it has a public IP address, so you can access it, again, for maintenance from the public internet. However, if we look at the DB0 machine, what do we see? Well, we see that it doesn't have a public IP address, which means it is only accessible from the Linux Bastion host. So what you would do is you would connect to the Linux Bastion host, and then from there you would connect to the DB0 machine or the DB1 machine or the Paso machine using that private IP address. All right. What can you do on the DB0 machine or DB1 or DB2? Well, it's a machine that is running OpenEdge, the OpenEdge database, so you can run any of the commands, proenv, promon, right? So at this point, once that the infrastructure has been created, it would look familiar to you because it's using the concept that you already know, right? So notice that the quick start, it's giving you the ability to go from what you already know to the cloud with concepts that maybe you don't know just yet, but they are packaged in an easy way to consume with infrastructure as code, and then it creates resources that you understand, that you know how to work with. The Paso machine is similar. It has a private IP address. One key point for the Paso machine is that the OpenEdge properties file uses a dbconnect.p file. There are some examples that I'm going to show you, and you can see the source code for this. And the idea basically is that the dbconnect.p file checks if the database is available to the agent, right? If the database is not available, what it will do is then it will try to connect first to the database running on DB0. If it fails, it goes to the DB1, and it fails, it goes to the DB2, and it uses basically the new option, the database alternate connection. All right. For the web server, it's the same story. It has only a private IP address, and again, you will generally would use this machine from the web UI. But if you need to do maintenance, then you connect using SSH, and then you can use the sudo systems CTL status nginx to check for the web server running, and then you can do troubleshooting if you need to. Okay, time for the second part of the demo. Let's go back to our web UI, web browser here. Notice that, and this, I'm going to refresh. Notice that Paso is running, right? The web server stack just started. We actually saw that in just a second that we switched. Notice that this create is in progress. So let me click here, and notice that you can see the events of the resources being created. You can see the resources that are being created. You can see the outputs. Well, there are no outputs just yet because the stack is still in progress, right? Still being created. And then let me go back to the parameters. And then here we can see the parameters passed to the web server stack. So in here, I want to show you the parameters. Notice the following, right? So let me start with the database stack. So in the database stack, we have the parameters. We can see that there is a database deploy package, and there is a deploy bucket, right? So these are the parameters passed either through the UI in the wizard or from the parameters in the command, right? The AWS CloudFormation command. And in here, then you have all the other parameters. If we go to the outputs section, we can see that this stack, the database stack, produced a DB host name, DB host name 1, DB host name 2 output parameters with these values, right? So this is a configuration, right, that is created dynamically, right? We're creating this again from scratch to a OpenEdge application, and we need to be able to set up some configurations that are dynamic. So the DB hostname 1 and hostname 2, these are dynamic, and then we provide this as output parameters of this stack, and then we pass them as input parameters to the next stack, the PASOE stack. Okay, and then you will see it here. So, and this, of course, it has also the deploy bucket. So we can see the PASOE deploy package passed tar.gc, and then this is passed here. And then if we go to the outputs, we have then the PASOE stack that is providing a URL. And let's click on this URL. Let's see what we get. And ta-da! We have a Progress application server for OpenEdge running now in the cloud using the OpenEdge on AWS Quick Start. And again, we started from scratch. Now we have a pass for OpenEdge server running. Okay, so let's go back to this configuration. So the web server is still in process, right? So how long does it take? Well, let's take a look at the EC2 instances here. Okay, so I'm going to open it up on a separate page. And then we sort this by the name of the instance. So we can see that DB0, DB1, DB2, they are running. We can see that the Linux Bastion is running. We can see that PASOE, 2 instances are running. And the web server, 2 instances are running, but they are still initializing. So this step, right, the cloud, the web server stack is not considered complete until that initialization completes, right? So now that CloudFormation has detected that the machine have been created, we can see that we have the web server stack create complete, and now in the outputs we can see that there is a URL, and if we click this URL, then now we have the application, right? So we have our OpenEdge application. Again, we started from scratch, from nothing, and then now we have an OpenEdge application running, and this is using actually like a web concepts, right? And then if we click on the customer view, we can see the customer table. And if we click on the state view, we can see the state table. All right. So this is the configuration that I wanted to show you on the OpenEdge on AWS Quick Start. Let me also here show you a little bit more on the infrastructure. Okay, so let's go back here to the instances. So we have these machines, they're running, and actually I want to connect to the DB0 machine. I cannot connect from the public internet, but as I mentioned earlier, we can connect using the Linux Bastion image because that's the only one that has a public IP address. Now, for this experience and on what I'm going to show you, I'm going to use the AWS Cloud9. This is not a requirement, but I find this configuration to be very convenient, and I'm going to use it then. So what I want to do is I'm going to create a new environment. I'm going to just call it demo, and then next, and I'm going to create just a brand new machine. For this purpose that I want to show you, the configurations is just fine, and I'm going to create a new environment. So basically what I'm going to do here is I am now running a environment, right, that is AWS Cloud 9. It looks like Visual Studio Code in the cloud. It's a different engine, a different IDE. This actually takes some few minutes to create, right? But the idea here is that I will show you how to connect to these resources from this Cloud9 machine. Okay, so let me go first on a couple of places here just to show you. So we have the instances. We also can see the security groups, right, mentioned earlier. We can see the load balancers configurations, right, two load balancers, and we can see also the auto scaling groups, which we are right here. And there's actually one configuration that I have from a previous deployment. Okay, all right. So in here, these are the instances. Okay, let me check that the Cloud9 environment completed. Okay, this is good. Let me open a terminal. So this is just a very simple, straightforward workflow. I'm going to copy my PEM file to this machine. I just did a drag and drop. And we can do ls-l. Here we can see the machine, the PEM file, 400, and then want to change it this way. What we want to do for this experience, this part, is to access the Linux Bastion host machine, right? So let me click here. I'm going to copy this IP address, right? So we come back here to the Cloud9 machine. And before doing SSH, I'm actually going to do a SCP operation because I want to copy this PEM file to the Linux Bastion host. Why? Because I will need to do SSH to the other machine, right? So this is basically the workflow to do this operation. So home, it said EC2 user, and there it is. And then, yes, this is the machine that we want to connect, and it copy the resource, right? Next thing is we do SSH -i, the PEM file, EC2 user, @, and then the IP address. And now we are connected to the Linux Bastion host machine. And then here we have the PEM file already with permission of 400 because we did the SCP file here. And we can do SSH -i, the PEM file, and then we can connect to any of the other machines. Let me actually show you here the connection to the machine DB1. So the DB1 machine has a private IP address. So I copy this private IP address. This IP address is private, it's not available from the public internet, it's only available through the Linux Bastion host. So that's why we're doing this process, okay? And then we go, and yes, this is machine that we want to connect to. And now we have connected to the machine. And from here, we can do PSC DLC bin pro env, and we have OpenEdge 12.2.6 running on this machine. And if we do a promon sports 2020, we can connect to the running instance of the OpenEdge database. Let me show you here then with the user control, right, what we have. Notice that on this machine, we have, this is DB1, we have the broker and promon. So these are the only users on this configuration. So it means that our web UI, this one right here, the customer view, right, is using the data not from this database because there are no connections, but it's using it from the other database. Which database? The DB0 database, right? And if you go to, I have here a GitHub project that you can go and browse at any time. Actually, here are some instructions that I will show you later in more detail. You can go to the code, sports app. You can go into the source code. Here, web speed and DB connect, right? Remember that I mentioned about that? And then it checks for the connection to the database, uses the PEF file. And if we go back, let's go to the app folder, pass. Here's the auto reconnect PEF file. And what we do is we connect to the DB hostname machine, DB hostname 1 and DB hostname 2, right? So this is the way that the connection is done. Okay, so let's go back to this machine. So let me actually switch from this machine to the DB0. Okay, so I exit here. I'm back now to the Linux Bastion host. I am going to connect to the DB0 machine. Okay, and then here we have 239 right here. We copy the IP address, and then we come back to our shell. And yes, we can connect. And now we are on the DB0 machine. Okay. And actually, one thing that you can see, if you take a look at the install folder, right, you have the app folder. You can find in here the deploy.sh script. And in here, you can access the file and you can see how it is implemented. Okay. Now, how this script should look like? Well, it depends on how you want to deploy your application, but you can specify the instructions here. So let's do again sudo psc dlc bin pro env 1226 for the OpenEdge database. Now here we can do promon sports 2020, and if we do user control and display all the entries, what should we see? Well, a bunch of connections. Why? Because this is the database that is serving our web UI, right? So we have basically two servers with 5 agents each for PaaS-OE that are connected to this machine, right? So we have it right here. So this is what is used for this connection. And to conclude this part, let's do something a little bit of let's try to experience what happens if we do a pro shot of this database. And let's do it this way, pro shot, right? All these multiple processes we do on conditional shutdown, and there we go. So shutdown is executed. So we are actually disconnecting the OpenEdge database from those PaaS-OE instances. Now, if this was a setup with database replication, and you did this, right, it's maybe because you want to migrate to the database target 1 or database target 2, or something happened to the database, so you would run the appropriate database replication commands. For this demo, I'm actually using just copies of the database. So for, let's say, the recovery, I only need to do a refresh on the environment. And then I refresh, I click here, customer view, and then it loads, and voila, we have an application that is resilient to, let's say, the shutdown of the database, right? So these are the concepts that we're handling here, right? We are handling high availability, we're handling scalability with the auto-scaling groups, right? And we are handling security because the two basically subnets, the private and the public subnet. Okay, so and this basically shows that you can use the OpenEdge and AWS Quick Start to get started with the deployment of your application, have an application deployed by default, and then after that you can just do your regular maintenance as you know how to do with OpenEdge applications. All right, so let's go back to the slides. I want to talk to you about one more topic here, automation. Right, so what we want to do is generally be able to run this type of configurations from a CI/CD pipeline, right? So run this from a script. So this is how the script would look like. So we specify there's a public bucket and a private bucket. The idea is that you can do customizations to the Quick Start code, right? So in here, there is a copy of that Quick Start code that is available in GitHub. And then you can call the AWS CloudFormation command, tell it to create a stack, specify the template, which is now using this public bucket, and then specify the various parameters that you want to configure. These are the same parameters that you saw when using the CloudFormation wizard, right? Then you specify the public bucket for be able to access the template files, and you specify a private bucket to access the database deploy package, the PaaS-OE deploy package, and the web deploy package. And by you specifying appropriately these DB, PaaS, and web packages, you can basically have an application that can run from scratch to a point that you have a running application at the end of running the wizard, right? And you basically access then the PaaS-OE URL if you want to access the PaaS-OE server, and the web URL if you want to access the web server component. And again, if you run this, whether using the wizard or running the AWS CloudFormation script, you get the same experience, right? So you have now a CloudFormation, basically stacks that are created, and then you can access your web OpenEdge application running ABL code. There's one more item that I want to tell you about, okay, and that's the deployment packages. So we touched about this briefly, but let me just highlight on this, right? So if your URL to the deployment package looks like this in the S3 syntax, let's say, right? You will have a deploy bucket, that's the parameter that is used, and then a package name. By default, the package name is db.gc. It's used for the db0, db1, db2 machine, and then it's also used on the and then you have PaaS for the PaaS-OE machine, and then web for the web machine. Okay. The structure is the deploy.sh script, a progress CFG file that you have to provide so that it can start the OpenEdge database server, the broker, and also for PaaS-OE. The package are deployed by using just this syntax. There is an environment variable called OEENV that is set to db0, db1, db2, PaaS-OE, or web, and then the deploy.sh script is run using install app deploy.sh. You can go to GitHub, browse the source code for the Quick Start, and you will find these instructions there. Then we have the environment variables, right? So there's some few environment variables that are set, right? The OEENV, these give you the ability to configure your deploy.sh to be conditioned to what type of machine it is running. You can have multiple copies also if you want. Then there is the DB host name 1 and 2 for configuring the location of the DB0, DB1, DB2 machines. This is something that you would use on the PASOE machine to be able to connect to the databases. And then you have PASOE URL that you would use from your web UI as a way to find where the REST services are. Okay, so what if you want to run this yourself? Well, you are in luck, because here are the steps on how to do this yourself if you want to. And you can do this today, right after this presentation. Okay, so you can go to the OpenEdge and AWS workshop, S3 Amazon AWS.com, OE AWS Quick QS, MP4 for a video showing you how this is done. You can also visit this GitHub page with the steps. And the idea here is that it creates a Cloud9 environment, somewhat similar to the one that we created during the demo. But the idea is here to provide a copy of Progress CFG and then use this script called download and deploy, so that you can deploy the deployment packages with your own Progress CFG file. What do you need? Well, you need a OpenEdge and a PASOE license for Linux, right? So you cannot use a CFG file for Windows for this experience. You need the Linux version. And then you can then use the wizard to go through the experience. In summary, the OpenEdge on AWS Quick Start is available today. You can use it for the deployment of ABL application, N-tier, database, REST, web UI. It provides security, scalability, and high availability using AWS principles. For the Quick Start, you can run it interactively with the CloudFormation wizard. You can run it programmatically using the AWS CloudFormation command, and the source code is available in GitHub. And with this, I want to say a thank you. Thank you very much for the opportunity to present this to you. And let's now open for Q&As. I hope that this has been really a great experience for you to see how to get to the cloud using OpenEdge, and maybe something that you can try. And if you need help, just let us know. Thank you.
So thank you, Edsel. I didn't receive any question during the presentation, but I'm pretty sure there will be questions once people try it out.
Okay, no, very good. Maybe one point that people generally ask is about the license, which license to use, right? So generally you would use a named server license for this type of deployments, right? Because you will deploy multiple machines, right? So that's the license to use.
Mm-hmm.
All right. So with that said, okay, I hope that you can give it a try. Again, I'm very happy for the opportunity, and then I guess till next time. Thank you.
All right. Thank you. Bye-bye.
Bye-bye.